Bismillah ar-Rahman ar-Rahim. We'll start this section, 9.5, alternating series. What the meaning of alternating series? Is a series whose terms are alternately positive and negative. If you look at this series, positive, negative, positive, negative, positive, negative, and so on. And the same thing, negative, positive. So I can have either this term, minus 1 to the power n, or minus 1 to the power n minus 1, or minus 1 to the power n plus 1, anything like that. That will make the series called alternating series. We have what's called alternating series test. If I have an positive, so the one who alternate the signs is this term or that term. Either will make it positive, negative, negative, or negative, positive, and so on. Then this series, it will converge when these two conditions are met. What are the conditions? The limit is equal to 0, the limit of an equal to 0, and an plus 1 less than an for all n, means it's decreasing. That will make the series, this alternating series, converge. Note, if the first condition does not met, if the limit is not equal to 0 or goes to infinity or minus infinity, then for sure, then we can apply the n-term test for divergence, where the limit is not equal to 0, so the series will diverge. But if the first condition satisfied, but the second does not, does not satisfy, is not satisfied, we cannot conclude anything. You need to think about another method. If the first one does not met, we can conclude that the series diverge. However, the second one will tell us nothing if it's not satisfied. Okay. For example, this one. This is 1 over n. This is my an. An equal 1 over n. Look at the conditions. An positive, yes. This is positive. But I have n, 1, 2, and so on. Okay. And it's one of these forms, yes. It's the second form. Yeah, so I have this. Okay, now we'll go to the conditions. First, what is the limit of an as n goes to infinity? That will be the limit as n goes to infinity of 1 over n, and that is 0. Done. Second condition, an plus 1 will be what? 1 over n plus 1. Okay. And that for sure less than 1 over n, which is an. Yeah, since the denominator is bigger, so the value is less. So the second condition satisfied. This is for all n. Actually, you don't need for all n. It is specific n also, it's okay. Now, that means what? That means right away, this series converges. What is a convergent series? Let me say is a convergent series. I'm starting with a very simple example. Conditions, an positive. This is the form. Limit. These are the two conditions. These are just something to start with, to call it alternating series. Then the limit equal to 0 or decreasing, then we say right away, this alternating series converge. Do we care it's minus 1 to the power n plus 1 or the other way? No. If it is minus 1 to the power n, the same thing. This is also alternating series. And it's the same as this one with the minus sign. So converge. And by the way, this series, they call it alternating harmonic series. Remember the harmonic series, where I have this? Don't forget, this harmonic series diverge. But this with minus 1 to the power n, it will converge. So they call it alternating harmonic series. Now let me go to more examples. Determine the convergence and divergence of this one. Okay, what I will do is this. Let me rewrite it as summation n equal 1 to infinity n. Here I have minus 1 to the power n minus 1, 2 to the power n minus 1. So this one I can rewrite it. I'm trying to make it very simple, huh? Minus 1 to the power n minus 1 times n over 2 to the power n minus 1. Now this is very clear alternating series. Alternating series. What is an? An is n over 2 n minus 1. Is it positive? Yes, it's positive. Well, this is alternating series. Now we need to discuss the conditions for this alternating series. First condition, limit n goes to infinity of this. It's 2 to the power n minus 1. So if you apply the limit, I have infinity over infinity. I can't do Limiter's rule. So it will give me what? 1 over 2 to the power n minus 1 ln 2. Apply the limit again. I have 1 over infinity, which is 0. So first condition met. Nothing to worry about. Now the second condition about being decreasing. What shall I do? Yeah, this is not direct one. It's a little bit tricky to show that an. You can do it using the derivative. You can take the. I think it will work. Take the function x over 2 x minus 1. Do the derivative. It should be negative. Or you can do it by algebraic things. Notice 2n greater than or equal n plus 1 for all n greater than or equal to 1. Okay. Now divide by n plus 1 and 2. And divide by 1 over 2n plus 1. What you will get? You will get n over n plus 1. This is positive value, so that will not make no difference. Greater than or equal to half. Okay. Now multiply, or this half, let me take it the other way. This half, I can write it as 2 to the power n minus 1 over 2 to the power n. And this will be less than now. I wrote it the other way, huh? Less than or equal n over n plus 1. Okay. That give me what? That give me n plus 1 over 2 to the power n is less than or equal n plus 1. I make it here, and this is make it there. N over 2 to the power n minus 1. Yeah. So that, this is what? This is an. By the way, what is an plus 1? It is n plus 1 over 2 to the power n, which is this one. This is an plus 1. So second condition satisfied. So right away, we say this series, that means this series converges. Yeah, I hope clear. Okay, as I said, either you will do it by using the derivative or this algebraic things. Also, it will make it clear. Okay. Now let me move to the next one. Okay, so this is my series. This is the series. What is AN? This is alternating series. Alternating series. What is AN? AN is n plus 1 plus n. Okay. So what is the limit? First condition. What is the limit of AN as n goes to infinity? This is n plus 1 over n, which is 1, not equal to 0. Right away, this series diverges. Not by the alternating series test, by the nth term test for divergence. Is not related to the alternating series. There is no relation with the alternating series test. Alternating series test will tell us nothing in this case. Another one. This is 2 over 1. Okay. Okay. This series, yeah, very clear. The limit as an as n goes to infinity. Yeah, very clear. I'm going to what? That limit to equal to 0. So this is okay. Yeah, by the way, this alternating, yes. Positive, negative, positive, negative, positive, negative. So it's alternating series. Alternating series. Okay. Is the limit equal to 0? Yes, the limit equal to 0. This is one thing. The second thing, an plus 1 less than or equal an? No. If we took it with the positive and a1, if I make it alternating, let me call it alternating, make it alternating. Summation minus 1, starting from 1. I want this to be positive, so n plus 1 with an. So it will be a1. A1 is 2. A2, 1. A3, 1. A4, no, A3, yeah. Yeah, A3, 1. A4, half. A5, 2 over 3. Now it becomes bigger, This bigger than this. A6, 1 over 3. A7, 1 over 2. So this is becoming bigger. So you cannot control it. So this is not met. Well, it's not satisfied. So what shall I do in this case? Forget about alternating series tests. You need to think about another way. Think about another method. Please note, alternating series test is only one direction. If this format or this alternating series where I have this is my positive, negative, and an are positive, then we say this series converge if these two conditions are satisfied. Other than that, we don't know. This will tell us just only one direction. It will tell us the series converge, nothing else. If it satisfies these two conditions. So I need to think about something else in this case. And I notice what? Yeah. If we notice, this one will be what? This one will be 1. And this one will be half. And this one will be 1 over 3. And this one will be 1 over 4, and so on. So S to N will give me what? I will have what? You have the harmonic series, which I know it will diverge. So this series diverges. Yeah, which is clear. So as I said, the most important this section, you know, if the first condition is not satisfied, diverge. If the second condition is not satisfied, we don't know. We need to think about another method to deal with this problem. Let me go now to these problems. Okay, what is this? Is this alternating series? Yes. I have minus 1 to the power n. And this an would be cosine pi over n, which is always, is it always positive? No, it's not always positive. Is it always positive? It will be what? N equal 1, it will be minus 1. N equal 2, it will be 0. N equal 3, it will be positive, negative. N equal 3, it will be positive. N equal 4, positive. N equal 5, positive, and so on. So it's positive from here. So we can deal with it as okay. Actually, this is very clear. It will diverge. Why? Actually, if we take it as a whole, take it as a whole, and like this one. So this will not converge. Why? Because what is the limit as n goes to infinity of this cosine pi over n? Also, we take it as this one. That will be what? It will be cosine pi over infinity, cosine 0, which is 1, not equal to 0. So right away, this series will diverge by the n-term test for convergence. Yeah, because if this goes to 1, this is plus minus, so that will not converge to 0. So that make it diverge by the n-term test for convergence. Okay, this one. We don't have minus 1 to the power n. Do we have that? Yeah. Okay. You notice cosine n pi. This is the same as minus 1 to the power n. This is the same. If n equal 1, we have cosine pi, which is minus 1. If n equal 2, that will be 1, which is minus 1 square. If n equal 3, that is minus pi again, which is minus 1 to the power 3. If n equal 4, that will be plus 1, which is minus 1 to the power 4, and so on. So this series, actually, I can rewrite it as minus 1 to the power n, which is this expression, times n over 2 to the power n. Okay. And that one is alternating, since this expression, which is, or this term, positive, and this is, I have the alternating, the one which will make it alternates, I have alternating series. Okay, now let's go to the conditions first. The limit of an as n goes to infinity. That will be the limit as n goes to infinity of what? n over 2 to the power n. That will be infinity over infinity. And that gives me what? 1 over 2 to the power n ln 2, which is 0. So the first condition satisfied. Now we'll go to the second one, which I think similar to this one somehow. Similar to this one. But let me do it now the other way. Let me do it using the function. I have f of x equal what? X over 2 to the power x. I need to find f prime. What will be f prime? F prime of x. Oops. F prime of x will be equal to derivative of the numerator 1 times the denominator minus derivative minus x times 2 to the power x ln 2 over 2 to the power x square. And that is equal what? If I take 2 to the power x common factor, I have 1 minus x ln 2 over 2 to the power x all square. And that equal 2 to the power x. No, cancel 2 to the power x. That's gone. I have 1 minus x ln 2 over 2 to the power x, which is negative. Since 1 not 1 minus x ln 2 is always negative. Yeah, I mean for x greater than 2. Yeah, that will be 2 ln 2, which is more than 1, and so on. So that will be negative. So it means an plus 1 less than an for n greater than equal to, and that's what I need. So the second condition satisfied. Right away we conclusion. Right, I'm sorry, I'll write the conclusion here. This series converges by the alternating series test. Satisfying the conditions, everything is okay. Now let me go to another one. Yeah. Okay. What will be that? Is it alternating? Yes, it's alternating. An is this, which is positive. So alternating. It's alternating series. Okay. Now what is an? This is my an. Check the limit of an as n goes to infinity. That will be the limit as n goes to infinity. 3. Let me take it to x. I think it's better. Let me write f of x. F of n equal an. So I have f of x is 3 square root x plus 1. Yeah, both are okay, but usually we do it with x. With f of x. That will be x goes to infinity. 3 square root x plus 1. Will limit rule works? No. It is infinity over infinity. But if you do limited rule, if you have square root over square root, it will go back to the original one after doing it second time. So you will not reach anything. So we'll do this trick about the square root, which is the usual trick. I know x is positive, so I can take here, I can take x as a common factor. I have 1 plus 1 over x. And here I can take square root of x as a common factor. I have 1 plus 1 over square root of x. So I have what? Limit x goes to infinity of what? Of 3 square root of x, square root 1 plus 1 over x. everything is positive. 1 plus 1 over square root of x. So this is cancelled, and you get what? You get 3 square root 1 plus 0 over 1 plus 0. So I'm getting 3, not equal to 0. So it's not related to the alternating series test. This series will do what? Diverge. By what test? By the nth term test for divergence. Is not related to the being alternating or not. Since this limit not equal to 3, so all of this limit does not exist. So it will not go to 0. This one, 3n over 4n plus 1. What shall we say? I think it's very clear. Yeah, this is alternating. And they have an is 3n over 4n minus 1, which is positive. Yeah. So what is the limit of an as n goes to infinity? Easily. That will be 3n over 4n minus 1, which is 3 over 4, not equal to 0. So right away, this series will do what? Diverges. Why? By the nth term test for divergence. This one, alternating, yes, it's alternating. Alternating series. An, this one, which is always positive. Okay, what shall I do with it? Yeah. What about the limit? First condition, limit n goes to infinity of an of n square over n cube plus 1. Degree of the numerator is less than the degree of the denominator. Right away, this will be 0. So first condition satisfied. Now we'll go to the second one. We have f of x will be x squared over x cubed plus 1. Find the derivative to check if that is decreasing or not. That will be 2x x cubed plus 1 minus 3x squared times x squared over x squared plus 1 all square. And that is what? That is 2x minus x to the power 4 over this one, which is always positive. And this I can write it x 2 minus x cubed over this. So this one negative, if 2 minus x cubed negative, since you have all the values positive, I wanted to increase to, it's starting from 1 up to infinity. And that is true. That implies x cubed will be greater than 2. Which means x greater than cube root of 2. So this series decreasing if x greater than cube root of 2, which is more than 1. So the series second condition satisfied. So you have an plus 1 less than an for n greater than 2. Yeah. For n greater than or equal to 2. Or for n greater than 1, let me say. Yeah, because at 2, it will be satisfied. So the conditions are satisfied. So right away, I can conclude n equal 1 to infinity. This series converges by what? By the alternating series test. Sometimes they call it AST. Huh? Yeah, AST. Okay. Okay. Also, we have this alternating series remainder theorem. For convergent alternating series, the partial sum for convergent alternating series, the partial sum Sn, if we calculate the series up to a specific value S, then we say we call it the error, which is the difference between the actual sum of the series minus the partial sum at up to capital N. This we call it Rn, we call it the error or the remainder. There is the theorem. If a convergent alternating series satisfies this condition, then the absolute value of the remainder, which is Rn, this is Rn, involved in approximating the sum. If I'm approximating the sum, and instead of doing all the sum, n equal 1 up to infinity, I'm doing it, this is Sn, here we have minus 1 to the power n, huh? Here I have Sn, which is the sum up to a capital N. They say what? The difference. This I can calculate. This one, it will be up to infinity. I cannot do. So, but they said what? The difference between these two, which is we call it the remainder or the error, it will be less than the next one, an plus 1. The next step, a capital N plus 1. Okay. Let me do it by this example. Actually, I put the numbers since we need the calculator to do that. Okay. This is my series. Is alternating? Yes. Is alternating series. Alternating. This is positive. Nothing to worry about. Okay. Now do the limit. To check. This is very clear is 0. First condition. Yeah, 1 over n factorial. Let me just make it clear. Limit 1 over n factorial, which is 1 over infinity. That will be infinity times infinity. That will be infinity. Okay. What about an plus 1? If I check second condition, an plus 1, which is what? 1 over n plus 1 factorial. And that is what? 1. It will be 1 over n plus 1 n factorial, which is 1 over n plus 1 times an. This one will make it less than or equal a. So this will be less than 1. No need for less than or equal, but it's okay. Yeah. So second condition satisfied. So this series convergent alternating series. So this condition satisfied. We have convergence right away. What he wants us to do, he wants us to approximate the sum of the following series by its first 6 terms. So I'm concerned about S6. I'm concerned about this, which is 1 over 1 factorial minus 1 over 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial plus 1 over 5 factorial minus 1 over 6 factorial. That will be my S6. Okay. By the way, if you do the calculation of this, yeah, I did it by the calculator. I mean, if you do it by the calculator, you're getting this value. Okay. Yeah, for sure, you will not see something like this in the example. You will see something like determine the number of terms, which is we'll talk about, because you don't have you cannot do the. I mean, you don't have the calculator to do that. Now the theorem is saying what? S minus S6, which is R6, which is the difference, is less than or equal A7. What is A7? 1 over 7 factorial, which is 1 over 5040. You need the calculator for sure. Okay. So from this, I have what? S minus S6 is less than or equal 1 over 50, 40. So S minus S6 is bounded between minus 1 over 50, 40 and 1 over 50, 40. Just the absolute value things. So S is between what? Between S6 minus this. Oops. There we go. So S is between minus 1 over 50, 40 plus S6 and 1 over 50, 40 plus S6. Yeah. If we do it by the calculation, so that means my S is between this value which is what? Which is this minus 1 over 50, 40 and between this. So the sum of the series will be between this and this, between these two values. Okay. And that I get it how? I get it when I do 6 terms, I have find S6, which is this one. And I know S minus S6 will be less than the next term, A7. 1 over 7 factorial. Then I did the calculation. Usually in the exams we have these things because this one you need the calculator, but we're not using the calculator in the exam. Okay. This one we did, and we showed that it's converging. Huh? We did it before. Actually, this one, what is it? It's converging. Okay. How many terms of the series do we need to add in order to find the sum of the accuracy? I want the error to be, what is the error? The error which is S minus Sn. This is the error. That I want it to be less than 0.0002. Okay. Okay. Now, the rule is saying what? This error is less than or equal Bn plus 1. So I want this to be less than 0.0002. What is Bn plus 1? The next term. Bn plus 1. Yeah, without the minus sign. Bn plus 1. That will be 1 over n plus 1 factorial. I'm considering this as Bn, huh? Considering Bn in this case is 1 over n factorial. This is my Bn without this alternating value. Minus 1 to the power. Okay. Now I need this to be less than 0.0002. 0.002. What is 0.002? It is how many? 0 is 3. Okay, that will be 2 over what? 10, 100, 12, 1,000, 10,000. Which is 1 over 5,000. So I want n plus 1 factorial to be greater than 5,000. When is that true? Okay. I need to check find n. So my question, such that n plus 1, call it capital N or small n. Since I am using capital N, let me use capital N everywhere here. Yeah. Capital N, such that, not I'm doing it in details, huh? N plus 1 factorial greater than 5,000. Yeah. If capital N equal 1, what you will get? 2 factorial. Yeah, this is too far. Huh? But I'm doing it from, yeah. If N equal, what, 2, 3, 4, let me go to what? 4, what you will get? Yeah. If N equal 4, I have 5 factorial. Did I reach? Yeah, it will be 1 times 2 times 3 times 4 times 5. 4 times 5, 20. 2 times 3 is 6, that's 120. No, I'm not reaching it. I need it to be more than 5,000. N equal 5. Then I have what? 6 factorial, which is 6 times 120, which is 720. No, I'm not getting it. If N equals 6, let us see what will happen. I have 7 factorial. What is 7 factorial? 7 times 720. Let me do it here. 720 times 7. As I said, this I'm trying to do it in detail. 0. This is 4, 1. This is 5040, which is greater than 5,000. Sorry, capital N, capital N. So this is correct. So how many terms we need to get this error? 6 terms. With 6 terms, we'll get this error. Yeah. Yeah, let me do another one, and then I will stop. Yeah. Determine the number of terms required to approximate the sum of the series with an error of less than this. So I want the error. I know that S minus Sn less than or equal Bn plus 1. Yeah. And I want the error be less than 0.001. So I want this to be less than 0.001. What is Bn plus 1? And by the way, this series converge. Is it alternating? Yes, alternating. Yeah, because this works with convergent alternating series. So you have An or Bn or N. Yeah, let me make this A better. So I'm using An usually. Okay, N is 1 over n to the power 4, which is positive. Limit. Let me do it quickly. An, that is 0. That's fine. How to check it will be diverge. Also decreasing. I mean decreasing. Yeah. What is An plus 1? Very clear. It's 1 over n plus 1 to the power 4. And that is what? 1 over n to the power 4 plus something. For sure, this is less than or equal 1 over n to the power 4, which is An. Everything is positive here. Okay. So it's decreasing. So an plus 1 less than or equal an or n. So that means this series converges. Okay. So it's a convergent alternating series. As this is convergent alternating series. So I have this relation. So as I said, S minus capital S, or S capital N will be less than a n plus 1. This is the rule. I want this to be less than 0.001. What is a n plus 1? A n plus 1, it's 1 over n plus 1 to the power 4. So I want this to be less than 1 over what? 1000. So I need n plus 1 to the power 4 greater than 1000. So I need to check which n will make it good. As we did, or either we'll solve it. Yeah, that will be what? Can think of it that n plus 1 greater than the fourth root of 1000. What is the fourth root of 1000? Yeah. The fourth root of what we know? 2 to the power. Yeah. Fourth root of 1000. And the fourth root of 2 to the power 4, which is less than, too much, less than 2000, 10,000. 3 to the power 4. That will be what? 81 still. 4 to the power 4. That will be 64 times 4. Still. 5 to the power 5. Well, you know what? I can check it the other way. I can check it by plugging the numbers the other way. I think it's better. Yeah. Instead of doing it this way. Yeah, sometimes this will work easily. Sometimes no. It depends on the power. If you can check or guess what is the fourth root of 1000, which is 6 point something, but you need to think about how to check it. Or I can do this. What n equal? Yeah, I can start with 4, for example. What you will get? You will get 5 to the power 4. What is 5 to the power 4? It's 25 times 25, which is 625. Okay. If n equal 5, what you will have? You can try less than 4, or you can start from 4. If it reach the value, then you go back. N equal 5, that will be 6 to the power 4, which is 36 times 36. Let me do the calculation. 36 times 36. 6 times 6, this is 36 again. 216. This is 8110. Very clear, this is growing more than 1296, which is greater than 1000. So how many terms to reach? I mean capital N, sorry. How many terms we have? We need at least 5 terms. At least 5 terms. Usually they will ask find the minimum number of terms. So it's 5 in this case. Yeah, in this case, I can say at least 6 terms. Huh? Because if it is more, for sure, it will make the convergence. Yeah, I think we talk about 2 things here. We talk about the alternating series test, which is, I think, very easy. Alternating series. These 2 conditions satisfied, then the series converge. The alternating series will converge. Also, we talk about this alternating series remainder, where the difference between the sum minus the partial sum up to n, capital N elements is less than the next term, n plus 1, without the minus sign. Yeah, I will stop here. Then I will do more examples, and then we'll go to the next topic in this section. Let me stop the recording. Thank you.